Hello everyone, welcome to our EE313 term project milestone video presentation. I am Halil Uçar. Our goal for this milestone was to design a purely analog circuit that maps varying input voltage to a continuous color spectrum on an RGB LED. The critical challenge here is the word is continuous. We cannot simply switch colors on and off digitally, so we need intermediate colors like cyan and yellow. To achieve this, we treated RGB LED control as a mathematical function, and also we created three separated analog channels with op-amps to control current flow through the red, blue, and green diodes independently based on input voltage. For the red channel, we utilize non-inverting amplifier topology. As the temperature increases towards 14 degrees, the output voltage of these op-amps will increase. Also, the current flowing through the red diodes will increase. Also, for the blue channel, we used differential amplifier topology, as you can see. It creates an inverse relationship. The output, the voltage increases, the flowing through the blue current will decreases. Exactly, I2. To solve this, we created a window function or triangular wave generator circuit with the op-amps and 1 and 41, 48 diodes. Also, we configured the op-amps to act as a slope generators, and one part of the circuit ramps up to the green current while we approach the midpoint, and the other part of the circuits ramp it down to the green current thanks to the diodes, and these diodes act as a soft switch. One of the main challenges that we faced during the milestone is the tuning the resistance values, because we had to ensure the colors mixed correctly at the right voltage. And now we will switch to our video of our circuit on the breadboard to demonstrate in real life performance.
Hello, my name is Mustafa Aykaya, a third-year student at METU in Electrical and Electronics Engineering Department. Today, we will present our first milestone. Firstly, we know that we need a temperature range between 24 degrees and 40 degrees. At 24 degree, the RGB LED must be blue. At 32 degree, it must be green. And at 40 degree, it must be 40. In our LT SPICE schematic, we use VPOT notation for potentiometer as the sensing unit. We use universal op-amp 2 in LT SPICE and TL081 in the laboratory. The most interesting and challenging part of the design was the green channel, as it need to be off at low temperatures and also at high temperatures, and it has a peak in the 32 degrees. So we used the window function to design it to obtain that bell curve shape for the green LED. We used resistors in the legs of each diode to limit the current to protect our LEDs. Here is our circuit breadboard design, and we obtained the continuous analog and smooth transitions for each color. Here is our video. For each color, there is a sweep transition between it. By using those different op-amp configurations, we obtained this analog shape. Here is our video. Also, I want to mention that we will use the sensing unit as the potentiometer at the further parts of the project. Thank you for listening.